Hi everybody, welcome back to another video on Feynman integration. Today we're going to be evaluating this integral that I originally saw on the channel Flammable Maths. The integral is the integral from 0 to infinity of sine squared x over x squared times x squared plus 1 dx. And I will link to his video in the description. We are going to be using a fact we discovered from a previous video. That video is from example 12. And in that, we discovered that the integral from 0 to infinity of sine tx over x times x squared plus 1 dx is equal to pi over 2 times 1 minus e to the negative t. And in turn, this was derived from previous examples. Those examples are 3, 5, and 10. Go ahead and watch those because this really builds on those previous videos. Again, that's examples 3, 5, 10, and 12. We will be using the result we got from example 12. So, and I'll also provide links in the description to those videos. So like always, we're going to create a function of t that closely resembles our original integral. In this case, I'm simply putting a t there right in front of the x to give us f of t is equal to the integral from 0 to infinity of sine squared tx over x squared times x squared plus 1 dx. Also, we will note that f of 0 is equal to 0 and f of 1 is equal to I. Pretty easy to see that. Using the Leibniz rule for differentiation under the integral sign, which is what this channel is about, we know that we can get f prime of t by taking the partial derivative with respect to t of the integrand of this integral right here. And that will give us f prime of t is equal to the integral from 0 to infinity of 2 sine tx cosine tx over x times x squared plus 1. Hope you can all see that. And we know that 2 sine tx cosine tx is equal to the sine of 2tx. So now we have an integral right here that is in that form. But instead of having sine tx, we have sine 2tx. So all we need to do is replace this t with a 2t, and we will have our expression for f prime of t. And that is written right here. I hope that all makes sense to you. So, we don't want f prime of t, we want f of t. But we know that f of t is equal to the integral of f prime of t, which in turn is equal to pi over 2 times the integral of this thing right here. And that's written right there. Evaluating that will give us that f of t is equal to pi over 2 times e to the negative 2t over 2 plus t plus a constant of integration. Plugging in f of 0 equal to 0 will give us that c is equal to negative pi over 4. Plugging c equals negative pi over 4 and t is equal to 1 will give us I. And that's written right there, giving us a final expression or a final answer, a final value for I being pi over 4 times 1 over e squared plus 1. And that's it. That's the answer to that integral right there. Extremely intimidating integral, made not so bad if we build upon things that we've already discovered. I believe the video that Flammable Maths put out, he just did this one from scratch. It's a really, really good video. I recommend you watch it. And again, I will post a link in the description. But you don't have to go through all that work if you use what we already know. So anyway, that's it. Hope you enjoyed that.